So this video will be serving us linear inequalities part 2, special in linear inequalities. And so we're going to look at that. Note, whenever we are dividing a linear inequality by a negative number, let's say we have negative 2x is less than 14. Now, whenever we're dividing by a negative number, we must swap or flip or change whatever inequality symbol that we have to the opposite one. So we can say that I will say x is, so in this case we would have negative 7. But then if we were keeping this, we would say x is less than negative 7. But what we will do is have to change it because it is being divided by a negative. Now look why we have to change it. If we should keep the same sign, seeing that it's being divided by a negative, look what happened. If we should choose any number, let's say that just choose a negative 6. Well, no, let's say negative 8 less than negative. Let us, because negative 6 is greater than negative 7. So let's say, let us choose like say x is less than negative 1, x is less than negative 7. So we would say we can choose a number like, let's say, I want to find a very easy one. Let's say 8. Let's say 8 because negative 8 is less than 7. So let's choose 8. If we should choose 8 and plug it into this equation, let us see what in this inequality. Just look at what will happen. If we say negative 2 times negative 8 is less than 40, let's see what happens. If we should multiply this, we get positive 16 is less than 40, which would not make the statement true. But what if we actually flip that we say 16 is greater than 40, and so then you actually see that it's actually true. So what we actually do whenever we're dividing by a negative, we always switch the sign to its opposite. So not only a negative, but if you're actually multiplying also by a negative, let's say we're multiplying by a negative. So let's say we have this is what, say 14. So we actually multiply by a negative, we're dividing by a negative. So if we're dividing by a negative, what we'll actually simply do is to create a fraction. We multiply, so the x will be by times 1 equal to 2 will be negative 2 will be times 14. And so 1 times x gives us back x, and we have negative 28. But when we look at the inequality sign, it is saying that x divided by negative 2 is less than, so we have to change it to its opposite. So we'll have x is now greater than negative 28. So there you go. Whenever you are solving inequalities, linear inequalities, if you're dividing by a negative, you flip the sign. If you're multiplying by a negative, you flip the sign. But if you're adding and subtracting regularly with a constant value, you don't change the sign. You just work though, just as it is. Now let us look at 2 more questions and then that's it. So look at this one. We're actually making x a subject. So we could actually work this out as if we have two sides of the equation, and then we would actually have to group like terms. So to transpose the like terms, have all the x's on one side and all the constants on the other side. I decide to choose I can have my anywhere, I would put my x on this side. I would take my x and put it on this side, put all the constants on that side. So let's say now making x a subject. So I'm going to add both sides by 18. So I could have changed the sign to an equal sign. That cancels that. So we have x plus 1 plus 18 is greater or equal to 3x. And then what we can simplify this part. So we have x plus 19 is greater or equal to 3x. And then we'll bring this x on that side. And so we say subtract x from both sides. That cancels that. And listen, we will not change. We don't have any need to flip the sign because we're actually subtracting. We're not multiplying by a negative or we're dividing by a negative. So we don't need to flip the sign. So we say that now 19 is greater or equal to 3x minus 1x. And so we'll have 19 is greater or equal to 2x. We're dividing by a positive. And so the answer would be x would be equal to 19 over 2. So that's when you have on both sides, you have x's on both sides. Now look at this. We're going to look at compound linear inequality. Compound. So just look at a compound question. So we'll be looking at the last question. It is called a compound question. Compound linear inequality. So when you look at this one, this is like having two inequalities coming together, where we can actually see this is one and this is another one. So they are compound. They are coming together, more and more coming together. But what we could simply do is to try to rearrange this inequality so the x only is left in the center or between the two inequality signs. So what we could do is to subtract both. We want to get rid of this positive 1 and this 5. So what we can do is get rid of the 1 first, since the 1 is further away from the x. So we could subtract both sides by 3 sides by 1, negative 1. So we're going to subtract negative 1 from here, and also here. That's how we work compound inequality. So subtract 1, subtract 1, subtract 1. So that one goes 1 from 16 gives us 15, and x. 1 from 31 gives us 30. And what we're going to do, we're going to do the same thing. We're going to divide 3 sides by 5. And so we have this divided by 5, this divided by 5, and this divided by 5. And when you check 5 into 15 goes 3 times less than or equal to 5 into 5 divided by 5x gives us x all by itself. And 5 into 30 goes 6 times. And so we actually have this x by itself. And this is saying x is less than 6 and greater than 3 or equal to 3. So that's how we read it. X is less than 6 and greater than 3 or equal to 3. So all the possible values of x is actually, it is between 3 and less than 6. So it could be 3 and 5 points. 0.999999999999999. So if you were to take any one of those values and plug it into this equation, it's supposed to satisfy the inequality. And so there you go. Remember, we looked at when you multiply by a negative or positive, you would flip the sign of the inequality. When you're doing compound inequality, what you do, you work 3 sides. So to have the x all by itself in the middle. So that's it. Hope you will get enough help from this video, and see you next time.